Hello, let us discuss about brute force pattern matching algorithm in detail. Brute force pattern matching algorithm. Brute force pattern matching is the simplest pattern matching algorithm. It works by comparing the characters of the pattern with the characters of the text one by one. The algorithm starts from the first position of the text and checks whether the pattern matches the text at that position. If all the characters match, the algorithm returns the starting position of the pattern in the text. If a mismatch occurs, the algorithm shifts the pattern by one position to the right and repeats the comparison process. This continues until a match is found or the end of the text is reached. Because it checks every possible position, the brute force approach is easy to understand but can be slow for large inputs. How it works. The brute force pattern matching algorithm works by sliding the pattern across the text one position at a time. At each position, it compares the characters of the pattern with the corresponding characters of the text. First, alignment is done. The pattern is aligned with the beginning of the text string. Next comes comparison. The algorithm compares characters from left to right within the current alignment. If a mismatch occurs, the algorithm stops the comparison at that position and shifts the entire pattern one position to the right in the text. If all characters match, a match is found and the starting index is recorded. The algorithm may continue to find all occurrences or stop after the first match, depending on the requirement. Finally, termination occurs when the pattern has been checked at every possible position in the text. In this example, the text string is abracadabra and the pattern is acad. The algorithm starts by aligning the pattern with the beginning of the text. It compares characters one by one from left to right. At the first few positions, mismatches occur, so the pattern is shifted one position to the right each time. This process continues until the pattern aligns starting at position 3 in the text. At this position, all characters of the pattern match the corresponding characters in the text. Therefore, a successful match is found at index 3. This example clearly shows how the brute force algorithm checks every possible position until the correct match is found. Features of the brute force algorithm. The brute force algorithm is an intuitive, direct, and straightforward problem-solving technique. It works by enumerating all possible solutions to a given problem. Many real-life problems are solved using the brute force approach. For example, exploring all possible paths to a nearby market to find the shortest route. Another example is arranging books on a rack by trying all possible arrangements to use the available space efficiently. In daily life, many activities naturally follow a brute force approach, even though more optimal algorithms may exist. Algorithm. First, start from the first character of the text. Next, compare the characters of the pattern with the characters of the text. If all the characters match, the pattern is found. If a mismatch occurs, shift the pattern by one position to the right. Continue this process until all possible positions in the text are checked. Implementation code. This program implements the brute force pattern matching algorithm using the C programming language. First, the standard input-output and string libraries are included. The text string is defined as Dept, and the pattern string is BCD. The lengths of the text and the pattern are stored in variables n and m. A loop is used to slide the pattern over the text from the first position to the last possible position. Inside this loop, another loop compares each character of the pattern with the corresponding character of the text. If a mismatch occurs, the comparison stops and the pattern shifts to the next position. If all characters of the pattern match, the program prints the starting index where the pattern is found. For the given input, the pattern BCD is found at index 1 and again at index 5. Time complexity. In the best case, the time complexity is O of n. This happens when the pattern mismatches at the first character itself at each position, so very few comparisons are required. In the worst case, the time complexity is O of n into m. This occurs when there are partial matches and mismatches, causing the pattern to be compared multiple times with the text. Another worst-case scenario is when all characters of the pattern match except the last one. In this case, maximum comparisons are performed at every shift, resulting again in a time complexity of O of n into m. Space complexity. The space complexity of the brute force pattern matching algorithm is O of 1. This means the algorithm uses constant space. It requires the same amount of memory regardless of the size of the input text or pattern. Only a few variables are used for indexing and comparison, so no extra memory is needed. Conclusion. The brute force pattern matching algorithm is the simplest and most straightforward method for finding a pattern in a given text. It works by comparing the pattern with the text character by character and checking all possible positions. Although the algorithm is easy to understand and implement, and requires only constant space, its time complexity of O of n into m makes it inefficient for large inputs. Therefore, the brute force algorithm is mainly suitable for small datasets and learning purposes. For practical and large-scale applications, more efficient algorithms such as KMP and Boyer-Moray are preferred.